When the Galactic Union first discovered Earth, the evaluation committee expected little. Their survey drones had catalogued thousands of developing civilizations across the spiral arm, and most followed predictable patterns. Species evolved physical advantages suited to their environment: armor, venom, psychic communication, regenerative tissue. The strongest tended to survive long enough to reach the stars. Humans did not appear to fit the pattern. The official report described them with surprising bluntness: fragile skeletal structure, minimal natural weapons, high susceptibility to disease, emotionally unstable behavioral responses, internally divided planetary governance. Even their sensory perception was considered mediocre by galactic standards. Their eyesight could not detect the wider electromagnetic spectrum. Their hearing was limited. Their bodies lacked natural defensive adaptations seen in more resilient species. Yet somehow, they had survived on one of the most unpredictable biospheres ever recorded. Earth's environmental profile raised several analytical anomalies. Temperature ranges fluctuated dramatically across the planet. Violent storms regularly reshaped coastlines. Microbial organisms displayed aggressive evolutionary competition, creating constant biological threats. Geological activity produced earthquakes, volcanoes, and continental drift patterns that forced species to adapt or perish. The Union had seen species collapse under far less pressure. But humans had endured. The committee initially attributed this survival to technological acceleration, primitive machines compensating for biological weakness. But deeper analysis revealed something unusual. Human advancement did not follow a stable progression. It followed crisis. Every major leap in their development came after catastrophic events. Wars pushed engineering innovation. Disease outbreaks accelerated medical discovery. Environmental collapse triggered energy revolutions. Scarcity produced creativity. Instead of being destroyed by hardship, humans appeared to reorganize themselves around it. They did not simply survive difficulty. They used it. Union observers classified humanity as situational innovators. Useful, but not exceptional. First contact protocols were initiated cautiously. The Union did not interfere directly with developing species, but communication signals were introduced at a distance, allowing humanity to discover the wider galactic community gradually. Human response was immediate and chaotic. Thousands of scientific institutions competed to decode the transmission structure. Independent researchers published theories hourly. Governments attempted to control information flow, but failed within days. Civilian networks translated fragments of the signal faster than centralized authorities. The Union expected panic. Instead, they observed curiosity. Within 22 years, an astonishingly short period by galactic standards, humans established their first stable interstellar communication array. Their technology was inelegant compared to Union standards, but it functioned. Trade agreements followed soon after. Human exports were unconventional. They offered problem-solving frameworks, adaptable software architectures, and modular engineering designs rather than rigid technological templates. Their creations were not always efficient, but they were flexible. Flexibility intrigued some Union species. It concerned others. The Varelian Consensus submitted a formal observation note. Human systems appear deliberately incomplete. Their designs anticipate future modification. They plan for change rather than stability. This approach contradicted most advanced civilizations, which pursued optimization and permanence. Humanity appeared comfortable with imperfection. For several decades, humans remained minor participants in interstellar society. They were cooperative, inventive, and unusually willing to collaborate across species boundaries. No one considered them a strategic threat. No one expected them to become strategically important. Then the Carthax expansion began. The Carthax did not negotiate alliances or trade routes. They did not conquer worlds for territory or ideology. Their civilization functioned according to biological efficiency. Every species they encountered was evaluated for useful evolutionary traits. Valuable traits were integrated. Inefficient traits were discarded. Entire ecosystems were converted into biological resource networks optimized for Carthax survival. When the Carthax encountered humanity, their analysis required less than 4 minutes. Limited natural weaponry. Short lifespan reduces knowledge accumulation. Genetic variability produces instability. Emotional processing decreases decision efficiency. Conclusion. Low-priority species. Earth was catalogued but not harvested. Humanity was ignored. To the Union, this seemed merciful. To humanity, it was a warning. For the first time in their history, humans were not being challenged by a stronger opponent. They were being dismissed as irrelevant. And humans had always reacted unpredictably when underestimated. The weakest species in the galaxy had just been given something no advanced civilization had offered them before. Time to decide what they were willing to become. The Carthax did not arrive with declarations of war. They arrived with silence. Entire star systems simply stopped responding. Trade routes went dark. Communication relays returned corrupted biological noise. By the time the Galactic Union assembled investigative fleets, the affected worlds had already been transformed. Planets were not destroyed. They were repurposed. Forests became nutrient distribution networks. Oceans were converted into biochemical processing reservoirs. Indigenous species were analyzed, altered, or dissolved into genetic libraries used to improve Carthax biology. The Carthax did not conquer civilizations. They absorbed advantages. Union military doctrine had always relied on superiority, stronger shielding, faster weapons, more efficient propulsion. Against traditional enemies, escalation produced victory. Against the Carthax, escalation produced adaptation. When Union forces deployed energy-based weaponry, Carthax vessels developed refractive biological plating that dispersed the energy across living cellular matrices. When particle weapons were introduced, Carthax organisms evolved microscopic defensive structures capable of destabilizing projectile cohesion. Each battle improved the Carthax. Each defeat strengthened them. Union predictive models calculated extinction probabilities across dozens of species. Even advanced civilizations with millennia of technological development could not maintain advantage long enough to secure victory. Humanity studied these reports carefully. Instead of focusing on Carthax strength, human researchers examined Carthax behavior. The pattern was clear. The Carthax did not invent unpredictably. They optimized. Their evolution followed logic. Efficiency guided every transformation. Humans recognized something immediately. Efficiency could be anticipated. Human history was filled with inefficient decisions that later proved essential. Evolution itself had never produced perfect organisms, only adaptable ones. Human research institutions began collaborating at unprecedented scale. Governments relaxed intellectual property restrictions. Corporate laboratories opened databases previously guarded for competitive advantage. A new global directive emerged. study adaptability itself. Genetic researchers revisited abandoned gene editing experiments once restricted by ethical regulation. Cybernetic engineers explored neural-machine interfaces previously considered too invasive. Artificial intelligence specialists developed symbiotic learning systems capable of integrating with biological cognition rather than replacing it. The debates were intense. Many argued humanity risked losing its identity. Religious leaders questioned the morality of altering human biology. Philosophers warned of unintended consequences. Cultural historians cautioned against abandoning traits that define the species. But a counterargument gained momentum. Humanity had never possessed a fixed identity. Their history was defined by transformation. They had altered environments, tools, languages, social systems, and belief structures repeatedly across thousands of years. Why should biology be considered sacred if survival was threatened? The question was no longer whether humanity should change. It was whether humanity could change fast enough. The Union expected disagreement to fracture human society. Instead, cooperation accelerated innovation. Human adaptation programs did not produce a single new form. They produced many. Some individuals enhanced cognitive processing through neural lattice integration, enabling real-time strategic modeling beyond natural brain limitations. Others modified immune systems capable of rapid environmental adjustment, allowing survival in extreme planetary conditions. Some humans adopted cybernetic augmentation, blending biological perception with machine precision. Others rejected modification entirely, choosing to preserve baseline humanity as a control reference for future development. Humanity did not converge toward a single solution. They diversified intentionally. For the first time in their recorded history, humans treated variation not as a flaw, but as strategy. The Union monitored these developments with increasing interest. Human technology did not stabilize into optimized form. It remained intentionally flexible. Systems were designed to evolve. Infrastructure was built to be replaced. Knowledge was distributed across adaptive networks capable of restructuring based on new information. Humanity was no longer attempting to become stronger than the Carthax. They were attempting to become less predictable than them. When Carthax exploratory organisms finally entered the outer human systems, they encountered something unprecedented. Human defensive networks did not respond with uniform resistance. Each system demonstrated unique environmental adaptations. Colonies in high radiation regions had engineered biological shielding into their habitats. Deep space installations employed distributed artificial intelligences capable of autonomous restructuring. Planetary defense systems integrated organic and mechanical components capable of repairing themselves mid-conflict. Carthax analysis systems attempted to categorize human responses. No consistent pattern emerged. Humanity no longer possessed a single biological profile, nor a single technological doctrine, nor a single strategic philosophy. They possessed something far more difficult to overcome: uncertainty. The weakest species in the galaxy had stopped trying to prove they were strong. They had chosen instead to become impossible to fully understand. And for the first time since the expansion began, the Carthax encountered resistance they could not immediately optimize against. The Carthax had never encountered a war they could not calculate. Their civilization had evolved around predictive adaptation. Every conflict in their recorded history followed the same principle: analyze the opponent, identify advantages, incorporate those advantages into Carthax biology, and eliminate the inefficiency. Victory was not an event. It was an inevitable conclusion of optimization. But humanity introduced an unfamiliar variable: inconsistency. The first major engagement occurred near the outer colony of Helios 9, a mining system located within a volatile radiation belt. Union analysts predicted swift assimilation. The Carthax deployed atmospheric conversion organisms designed to restructure planetary surfaces into nutrient-harvesting ecosystems. Instead, the organisms failed within hours. Human colonists had engineered microbial countersystems capable of rewriting cellular behavior faster than Carthax organisms could stabilize their genetic structure. Instead of attacking directly, the human-designed microbes introduced rapid mutation loops, forcing Carthax biology into self-conflicting adaptations. The Carthax adjusted. They always adjusted. But before they could deploy an optimized countermeasure, the environment changed again. Human orbital platforms released autonomous fabrication drones capable of constructing defensive structures mid-conflict. These structures did not follow conventional military architecture. Some were temporary radiation amplifiers designed to destabilize biological matter. Others were signal disruption matrices that interfered with Carthax coordination processes. Each defensive measure appeared unrelated to the last. Union observers struggled to classify human strategy. Traditional doctrine emphasized consistency and efficiency. Human strategy emphasized possibility. When the Carthax attacked the oceanic world of Nereid Colony, they deployed aquatic assimilation organisms designed to convert planetary oceans into biological resource reservoirs. The Carthax expected minimal resistance. Aquatic civilizations rarely developed complex military systems due to environmental constraints. Instead, they encountered human-engineered neural coral networks capable of transmitting real-time tactical information across entire ocean basins. Human divers enhanced with adaptive respiratory systems coordinated with semi-autonomous mechanical organisms that functioned as mobile support structures. The battlefield itself appeared alive. Human defenses did not simply resist invasion. They transformed the environment into a constantly shifting obstacle. Carthax predictive algorithms began producing contradictory probability forecasts. Human response patterns contained deliberate inefficiencies that made optimization difficult. Sometimes humans deployed overwhelming force. Sometimes they retreated strategically. Sometimes they introduced entirely new methods without apparent precedent. Human decision-making did not follow linear improvement curves. It followed creative divergence. Union war analysts identified a disturbing realization. Humanity was not attempting to win individual battles. They were attempting to exhaust the Carthax ability to predict future battles. Every engagement forced the Carthax to invest biological resources into adaptation. Every adaptation increased biological complexity. Increased complexity reduced adaptation speed. Humans were not competing for strength. They were competing for tempo. The turning point occurred during the conflict near the binary system of Vega Delta. Carthax forces deployed multi-environment assimilation organisms capable of operating in vacuum, atmosphere, and high-gravity conditions simultaneously. The organisms were designed to eliminate the need for situational specialization. They were efficient. Human response was inefficient by comparison. Human fleets entering the system consisted of incompatible ship designs, experimental propulsion systems, and hybrid organic-mechanical pilots whose neural patterns differed significantly from baseline human cognition. Carthax analysis systems identified thousands of structural inconsistencies. Predictive modeling failed repeatedly. One human vessel intentionally overloaded its own propulsion matrix, releasing a cascade of unstable particles that disrupted Carthax's biological cohesion. Another deployed localized artificial gravity fluctuations, destabilizing the structural integrity of multi-environment organisms. A third vessel allowed itself to be partially assimilated, only to activate embedded counterbiological systems designed to disrupt Carthax's internal coordination networks. Human tactics did not avoid risk. They used risk as a weapon. The Carthax began allocating increased resources to modeling human behavior. Each model required revision. Each revision consumed time. Time reduced adaptation efficiency. For the first time in recorded history, Carthax's expansion slowed. The Galactic Union observed a transformation in strategic classification databases. Humanity was no longer categorized as biologically weak. They were categorized as strategically unpredictable. Unpredictability could not be absorbed. It could not be genetically replicated. It could only be endured. And endurance was something humans had practiced long before they ever reached the stars. The weakest species in the galaxy had discovered a method of warfare the Carthax could not optimize against. They made change itself the battlefield. Despite slowing the Carthax expansion, humanity could not stop it entirely. Every unpredictable victory came at a cost. Human adaptation programs required constant revision. Hybrid technologies introduced unforeseen side effects. Some enhanced soldiers experienced neural instability from rapid cognitive modification. Some cybernetic integrations produced sensory overload. Some biological alterations created vulnerabilities that had not existed before. Adaptation provided advantage. But adaptation also carried risk. The Carthax, meanwhile, continued learning. They began avoiding direct confrontation with heavily modified human forces. Instead, they targeted something far more vulnerable. Origins. The Carthax deployed a planetary assimilation organism toward Earth. It was unlike previous invasion constructs. Rather than attacking military infrastructure, the organism targeted biospheres directly. Its function was not destruction, but replacement. It would integrate itself into the planetary ecosystem, gradually rewriting biological processes until Earth itself became a Carthax-controlled resource network. The Union had witnessed this strategy before. No civilization had successfully defended its homeworld from biosphere assimilation. Weapons could destroy fleets. They could not easily destroy a planetary infection spreading through air, water, and soil simultaneously. Human Strategic Command assembled representatives from every major colony, research network, and governance body. The meeting was not broadcast publicly, but fragments of its content later entered historical archives. The core question was simple. Should Earth remain unchanged? Earth was more than a planet. It was the birthplace of human identity. Every culture, language, and belief system traced its origin back to the biosphere now under threat. Some leaders argued that altering Earth's natural systems would mean abandoning history itself. Others argued that survival required transformation. Scientific projections indicated that conventional defensive measures would fail within 18 months. The assimilation organism was designed to adapt at the microbial level. Every ecosystem on Earth would eventually become a Carthax-controlled biological network. Humanity could attempt evacuation. But evacuation meant surrendering their origin permanently. A radical proposal emerged from a coalition of biological engineers, environmental scientists, and adaptive systems researchers. Earth itself could be redesigned. Instead of defending the biosphere, Humanity could convert the entire planetary ecosystem into a self-modifying network capable of resisting assimilation. Oceans could host engineered microbial systems that detected and neutralized foreign genetic patterns. Forests could develop symbiotic root communication capable of distributing defensive biochemical signals globally. Atmospheric composition could be subtly adjusted to disrupt Carthax's biological signaling processes. Earth would not merely resist invasion. It would behave as an immune system. The proposal carried irreversible consequences. Many natural species would change. Climate patterns would shift. Entire ecosystems would evolve beyond historical form. Future generations might inherit a planet biologically different from the one humans originally evolved on. Debate lasted for 71 hours continuously. Religious councils questioned the morality of redesigning a planet. Historians warned against severing continuity with the past. Cultural leaders argued that identity required preservation of origin. But another perspective gained influence. Human history had never been defined by preserving environments unchanged. Humans had always reshaped their surroundings. Agriculture altered landscapes. Industry transformed atmospheres. Technology redefined communication. Adaptation had always been part of survival. Perhaps Earth's greatest contribution to the galaxy was not its oceans or forests. It was the beings it produced. Beings capable of choosing transformation over extinction. The final vote was not unanimous, but it was decisive. Humanity approved planetary redesign. Implementation began immediately. Orbital platforms deployed atmospheric adjustment systems designed to introduce controlled biochemical regulators. Oceanic research facilities released engineered microorganisms capable of adaptive defensive mutation. Forest ecosystems were seeded with symbiotic communication networks enabling coordinated environmental response. Earth began to change. Not violently. Not catastrophically. Gradually. Intentionally. For the first time in recorded history, a species chose to alter its own origin world not for comfort, but for survival. The Carthax assimilation organism reached Earth 8 months later. It encountered something unexpected. The biosphere was no longer passive. It was responsive. Every attempt to integrate foreign biological material triggered localized adaptation responses. Ocean chemistry adjusted to disrupt invasive genetic replication. Soil microorganisms rewrote their own cellular structures to prevent assimilation pathways. Atmospheric regulators interfered with Carthax's biological communication signals. Earth did not reject the invasion instantly. It learned from it. Humanity had made the strongest decision any species could face. They chose to change the past in order to protect the future. The weakest species had risked losing everything familiar, because survival had never belonged to the strongest. It had always belonged to those willing to evolve. The Carthax assimilation organism entered Earth's atmosphere expecting compliance from the biosphere. Every previous world had followed the same sequence. Initial microbial resistance would collapse under adaptive pressure. Native organisms would be repurposed. Biological systems would reorganize into optimized energy pathways supporting Carthax expansion. Earth did not collapse. It responded. Within hours of atmospheric entry, the assimilation spores encountered resistance at the microscopic level. Engineered oceanic microorganisms identified foreign genetic coding and initiated rapid mutation cycles designed to destabilize invasive replication processes. Instead of allowing integration, Earth's biosphere forced the Carthax organisms into constant evolutionary recalibration. Every adjustment the Carthax made triggered further environmental adaptation. The oceans altered chemical ratios in localized regions, interrupting biological signaling pathways required for coordinated assimilation. Forest networks transmitted biochemical signals through engineered root symbiosis, allowing ecosystems separated by thousands of kilometers to respond as unified defensive systems. Earth behaved less like terrain, more like a living organism. Human orbital monitoring stations observed biospheric changes in real time. Atmospheric regulators adjusted trace gas compositions in response to Carthax metabolic requirements. Soil microbiology altered nutrient cycles to disrupt foreign biological resource extraction. The Carthax had never encountered a planetary ecosystem capable of strategic resistance. Assimilation required stability. Earth provided variability. The invasion slowed, then stalled. Carthax biological processors attempted to model Earth's adaptive patterns, but the rate of environmental transformation exceeded predictive thresholds. Every environmental modification created new variables. Each variable required additional adaptation. Adaptation required time. Time reduced expansion efficiency. Human strategy had not focused on defeating the Carthax directly. It had focused on making victory too expensive to achieve. Galactic Union observation fleets recorded a phenomenon never before documented. The Carthax began withdrawing biological resources from Earth's orbit. Not in retreat, in recalculation. For the first time since their emergence as an expansion civilization, the Carthax encountered diminishing returns on assimilation investment. Humanity did not celebrate immediately. Earth had changed. Ocean coloration shifted due to engineered microbial networks. Forest structures developed new growth symmetries optimized for communication efficiency. Atmospheric light scattering patterns produced subtle variations in sky coloration. The planet remained habitable, but it was no longer historically identical. Human cultural institutions began documenting the transformation as the continuity event, the moment humanity chose identity as a process rather than a fixed condition. Children born after the planetary redesign would inherit a world intentionally shaped for resilience. They would grow up understanding that survival sometimes required letting go of familiar forms. The Galactic Union updated humanity's classification record. Previous designation. Evolutionary inefficient. Revised designation. Adaptive civilization. Variable form. Union philosophers debated the implications for centuries. Most advanced species pursued perfection. Humans pursued possibility. Perfection required stability. Possibility required change. The Carthax eventually redirected expansion vectors toward less resistant regions of space. Their civilization remained powerful, but their models now included uncertainty parameters previously considered negligible. Humanity had introduced a strategic complication into galactic evolution itself. Strength was no longer defined solely by technological superiority or biological advantage. Strength could also emerge from willingness to transform identity. Human colonies continued diversifying. Some populations maintained baseline human biology, preserving continuity with ancestral history. Others explored deeper integration with adaptive technologies. Still others experimented with environmental symbiosis, living in partnership with ecosystems capable of mutual evolution. Humanity did not converge toward a final form. They abandoned the concept entirely. The Galactic Union gradually adopted new strategic doctrines influenced by human philosophy. Flexibility became recognized as a form of power. Diversity became considered a defense mechanism rather than inefficiency. Humanity never claimed victory over the Carthax. Victory implied finality. Humans had learned to distrust final states. Instead, they accepted something more complex. Survival was not a destination. It was a continuous decision. Across the galaxy, civilizations began reconsidering their own definitions of strength. Because the species once dismissed as weak had demonstrated something unprecedented. They did not defeat the most adaptive enemy in the galaxy by becoming stronger. They did it by becoming more willing to change than anything the galaxy had ever encountered. The weakest species had made the strongest decision, and in doing so, they ensured they would never again be defined by weakness.